Welcome all to another TIFR problem solving session. So the question that we have with us today is a pretty unique question. Okay, uh, it actually uses only one. You can say that only one concept that is, pretty common. Okay, so as you can see, the question is this: that if you have a matrix space and you have the all real valued continuous function on x, then infinite, even only the dimension of this is infinite. All right. So in other way around, what it is actually implying is that if the dimension of has finite dimension, if it has finite dimension, this implies x is finite. All right. So how will we proceed with this? See, if we know that if V is a vector space, and let's say for this case I have finite dimensional. So if you have V, a vector space that is finite dimensional, then V is always isomorphic to the dual of V. Right? So that is the collection of linear functionals. So the moment I have C of x comma r as finite dimensional vector space, this implies that the dual of Cx comma r is also a finite dimensional vector space. Now the dual actually is generated by the evaluation map. Okay, so what are evaluation maps? So evaluation maps are something like this: that if you take evaluation at x naught being an element of x, so this is a map from C of x comma r to r, taking f goes to f of x naught. So that is why it is a linear functional. That is why this evaluation map belongs here. Now you can check, this is a pretty standard check, that the evaluation maps are always linearly independent. So that means what, if you put x0, x1, x2, whatever you take point, evaluation functional at that point will always be a collection of linearly independent subsets. So now since C x comma r star is finite dimensional, that means what, there, if you take the evaluation functional, it cannot have more than n points, or let's say finitely many points, because since this is finite dimensional and evaluation map at every point are always, evaluation collection of evaluation maps at every point always gives us a collection of linearly independent subset or a linearly independent set. That is the reason that this dual space being finite dimensional implies that that is generated by this type of set, evaluation of x naught to xn. So now there cannot be any other point in x as well. So now the concept that you need to understand here is that there does not exist any point apart from x naught to xn in x. Why is that the reason? Because if there existed an xn plus 1, then let me call this as capital EV set, so then capital EV will not have been the basis of C x comma r star. Why? Because then evaluation of xn plus 1, this is also linearly independent with each of these things. Hence, it will has to be inside the basis set. Okay, so that is the reason if C of xr has finite dimension, then x is finite. Now the other directional is pretty trivial. Like if x is infinite, then you have these evaluation maps x naught, and it goes on like this as a basis for C x comma r stuff. So since the dual is infinite dimensional, the vector space will also be infinite dimensional. So this way around is infinite dimension. So this way around it's pretty simple. So the other way around is something what. So the only thing that is a very small exercise, you can actually do it yourself, is that evaluation maps always forms the basis of the dual set. So if you study vector spaces and its dual, you will find it in any standard book, but you can also try it by your own as well. Okay, so this is the fact that is needed. So what did we actually use here? So the thing that we basically used here was this, that first we proved that if this is finite, then x is finite. So then we proved that if x is infinite, I mean x is infinite, so see Cxr, so if you have C of xr as finite dimensional, this implies x is finite, right? So what does this imply? That implies that if x is infinite, then that is of infinite dimension. Okay, so which is a very easy way to understand here as well. So now let's just say if C of xr had infinite dimension, would x be of infinite dimension? Because yes, because if Cxr has infinite dimension, then if x had finite dimensional, if x was finite, then this evaluation maps would have formed the basis. Okay, so hence this is a both way statement. So Cxr, it has finite dimension if and only if x is finite. All right, so that is what we had here, and hence this statement is true. Okay, so thank you for joining. We will meet next time with another problem from TIFR.